Hello. So my Calculus 3 class recently, Calculus 3, we've been dealing with things like finding the distance from a point to a line. So find the distance. We actually just covered this from a point to a line. So we just had a test on this actually. And for us this was chapter 12. So let's see. Essentially we were given a point. I'm looking off at my notes over here. S not on the line, which was -1, -4, and 3. And then we had a parameterized equation, x equals -3 minus t, y equals -5, I think plus 2, yeah, plus 2t, and z was equal to y minus, or 1 minus 3t. All right, and so I'll write the distance equation here because that's kind of what let me easily see this, which is PS V cross product, and that's over V. And I'm pretty sure it's this. Let me check real quick. Can I pause this? No? I'll cut here. Hold on. Coming back now? Yeah, okay, so it is this. I had originally written it wrong, but yeah, this is it. So it's the magnitude of the cross product of PS and V over the magnitude of V. And so, well, we need everything here, so we have V, or do we? We have S for sure, we need P and V, and then we can just calculate everything else. And it doesn't give you it, seem to give you it, P or V and P, but you can find them because it actually does, and they're in this equation. And to solve the problem, essentially, the trick was you had to realize or remember, however, that x for a parameterized linear equation here was, let's see, v1t plus x sub 0. Y was similarly v2t plus y sub 0. It should be a sub here. And z was v3t plus z sub 0. And then you see x 0, y 0, z sub 0 here, get this in frame here, makes up a point, P. An initial point, a starting point, a point on the line, because it's in the line equation. And then V1, V2, and V3, V1, V2, V3 is generally just a vector, V. So now you've got P and a vector. There you go. And that was the hardest part of it, essentially. That was the thing that made it challenging. I know to a lot of students, probably. And so PS, I'll go ahead and show you how to do that as well. PS is just component subtraction, essentially. So components of S minus components of P. So S is, try to get this in frame here, S is -1, so -1 minus, let me draw a little box here so I can go back to it, P, I'll go ahead and put P here, p equals, identify that that's -3, -5, and 1 for x sub o, y sub o, and or sub naught, however you like, and z sub o, z sub 0. And so that's, where is it? -1 minus -3, comma, -4 minus -5, comma, and 3 minus 1. Okay. And that is 1 plus 3, 2, and 1, negative and positive, and then 2. That's PS. And then we want to find V, and we can, I guess, we've known this, but I'll do it formally here. V is, I won't put a direction vector notation because it doesn't have it here in the formula, the way I wrote it, but it is a vector, of course. V1, 2, and 3, that'd be the coefficients of the t's, so -1, 2, and 3, -3. And then we can cross product these two. Cross V, because that's what the formula calls for. And I won't explain the formula here. I'll just do the solution to this problem, essentially, if you're watching this and working something similar out yourself. And that is, so PS first, 2, 1, 2, and V, -1, 2, 3. I don't do it like the book does. Our professor actually taught us this diagonal method, so I, 1, 3, so diagonal like this. So the I term, or component, is 1 times -3, so -3i. And then plus j this way, because you've already gone in the center, so now up and then back down to the bottom, so 2 times -1, -2j, plus k, so I've done middle, outskirts, now I'm going back down, essentially here, so up and then up again. That makes sense. And so 2 times 2 is 4, k. And then minus kji. So this way now, k, so k, 1 times -1, k minus, let's see, j, so this way and then this way, the corners kind of for this type. 2 vectors, 3 dimensions, so 1, 2, 3, etc., x, y, z. So that's 2 times -3, so that's -6, j, and then I is 2, and 2 is positive, minus +4, I. Make sure you can see that. Okay. And then we're going to just evaluate this, so -3, where's the I? 6, should just be +3, because it's +6. And then -2j, actually that was an I supposed to be, so that should actually be +1 I, and then 2, 6, that's 5, 4, it's negative, goes to positive, and then 4, that's 5. So should this be minus minus? So that's actually, let's check this for a sec. So negative, and then negative here, because it's minus a negative. That 6 is from there. Okay. Make sure I did this correctly. Okie doke. So I'm getting -3 minus, or plus a positive, I keep getting the 6 here, plus a positive, or actually -4, that's what it is. The minus here should be minus, so maybe look like a plus. So that should be -7. That makes much more sense. -7, okay, look out for that. Huh. Maybe it's just me. So that's a -7 here. I'll actually write it under so it's more obvious. -7i. Alright, and then that's it. -7i plus, I'll just rewrite it again, 4j plus 5k. That's our cross product of P and S. Now, put this up here. We need to do the magnitude of V. And the magnitude of V is, where V, I'll just write V again. I'll just move it up actually. V is right here. -1, 2, and -3. So 1, 2, 3, 9, 10, 11, 12, 13, 14. So that's gonna stay. Actually, can't do anything with this. Can't like simplify it at all. So that'll be P cross product of V, or cross V, that's how you say it, I think. 4j, 5k, and I'll just go ahead and say this is, I'll write it like this, over the magnitude, so there, 14, that's 7 over 14, square root of 14, and that's negative, so I'll just put an I there, plus 4, so 4 square root of 14, then plus j, plus 5 over square root of 14, okay. Alrighty. And so I'm going to go ahead and actually put this into the magnitude, because the entire thing we want the magnitude of, oh, it's not in frame, we want the magnitude of the entire thing. So -7 over square root of 14 squared plus 4 over square root of 14 squared plus 5 over square root of 14 squared, and that's just going to be 49, 14 plus 16, 14 plus 25, 14 square root of 3, or 3 over 7 square root of 35. That's your distance.